All right, welcome back. So this is our next topic in Unit 4. We're going to solve log equations now. The idea of solving a log equation is you have an equation that has more than one or more logarithms in there. We're typically using the definition of logarithms to rewrite them as exponential and solving them. But if we can get two logs, one log on the left side, one log on the right side, and that's it, then the insides will definitely be equal to each other. Using the properties of logs to condense them will be necessary. So when we're adding two logs, we multiply the insides. Subtracting two logs, we are dividing the insides. Biggest thing though is we need to always check our answers to make sure nothing is extraneous. Because unlike the exponential, where x didn't matter, if we remember from our graphs, the domain of an exponential function is all real numbers. The domain of a log function is restricted based on can't have a negative or zero inside the log. So we have to always check to make sure we're not getting that. So we have the two logs on both sides equal to each other. They have the same base, therefore the insides are equal. 1 minus 3x is equal to x squared minus 3. We could recognize this as a quadratic trinomial because we have x squared and x in there. So we move everything over. X squared plus 3x minus 4. And we get x plus 4 times x minus 1. X equals negative 4 and positive 1. Now, we always need to check both answers, and as I've done purposely in this particular question, never assume the negative fails and the positive works. Because while you can't have a negative inside, that never says x can't be negative. We just have to see what happens. So when we check both these answers, we have log 117 of 1 minus 3 times negative 4, which becomes log 117 of a positive 13. Because negative 3 times negative 4 is a positive 12, plus 1 is 13. On the other side, log 117 of negative 4 squared minus 3 is also going to be a positive 13. So that part is good. Whereas when you try to substitute the 1 in, log base 117 of 1 minus 3 times 1, we get log 117 of negative 2. And while we will ultimately find out that they both sides have it be negative 2, which is great that they're the same, but we can't solve it that way. It can only be solved and work if we get a positive inside. Can't have a 0 inside, can't have a negative inside when you substitute in. And again, x can be negative, as we just saw right here. Negative 4 is perfectly valid, whereas x equals 1 is not. So don't assume you can't have a negative answer for x. Don't assume 0 can't be an answer for x. Always substitute in and see what happens when you solve out the problem that way. Now, if there's a single log in the problem, the idea is to isolate it, and then we can rewrite it as an exponential. So for this particular case right here, we would subtract the 2 over. Negative ln of x minus 3 equals negative 1. So therefore, ln of x minus 3 equals positive 1. And we always rewrite by using the base of the log to raise both sides of that power. So I'm going to do e to the ln of x minus 3 and e to the first. Because e cancels ln, so it's just x minus 3, and e to the first is just e to the first. So x equals e plus 3, which, using our calculator, e plus 3 gives us a decimal value of 5.718. We can check that back in. 5.718 minus 3 is a 2.718, so we're totally okay. We got two logs in the problem now, but there's also a non-log adding with it. So we generally want to group all the logs together on one side so we can properly condense it. So that would rewrite as log base 7 of 1 minus 2x plus log base 7 of 3 minus x equals 1. Properties of logs, when we are adding two logs together, we can condense that by multiplying the insides. It becomes log base 7 of 3 minus x minus 6x plus 2x squared, which when we rearrange and combine, we get 2x squared minus 7x plus 3. We do 7 raised to both sides to cancel the log, so that gets us 2x squared minus 7x plus 3 equal to 7. Subtract the 7 over, 2x squared minus 7x minus 4, and then we go ahead and factor that thing. We will find that this will factor as 2x plus 1 and x minus 4, giving us x equals negative 1/2 and positive 4 as our possible answers. Substituting the negative 1/2 into the problem, 1 minus 2 times negative 1/2 becomes a positive value, so that's okay. 3 minus a negative 1/2 is also, again, a positive value, so we're fine. Whereas 4, 1 minus 2 times 4 is a negative value. Once again, the positive failed and the negative worked for the value of x. Again, creating these questions on purpose just to show you that you don't have to have positive answers working and negative answers failing. Values of x just work based on whatever the value of x happens to be. Now in this scenario right here, again, we still have the same base, and they kind of do need to be the same base. If we ever have problems where they're different bases, they would hopefully have to be based on each other, so like a log base 2 and log base 4 in the same equation, we could work with that, otherwise it gets a little messy. But when they're the same base, we just go ahead and group them on the same side. So we subtract this log base 2 over. And because now we're subtracting, this condensing is division. So it's x plus 3 over 6 minus x. We then do 2 raised to both sides to cancel the log. So it's x plus 3 over 6 minus x equals 8. That's really like an 8 over 1, so we can cross multiply. And we can solve out for x. You add the 8x over, getting 9x. Subtract 3, getting 45. X is equal to 5. And we check it. 5 plus 3 is 8. We're good to go. 6 minus 5 is 1. We're good to go. Therefore, that's a valid answer. It's possible that the only answer we get to solve out algebraically might fail when we do our checking to see if you're going to get a negative inside the log. If that's the case, then we just go ahead and go, oh, okay, then the answer is no solution. And again, it's a simple matter of just substituting in 5 plus 3 is 8. That's good. 6 minus 5 is 1. That's good. You can trust that your math was correct. If you want to go a little further, you could then check log base 2 of 8 is 3. Log base 2 of 1 is 0. 0 plus 3 is 3. 3 equals 3. It is a valid answer. But for the most part, we're just more checking to make sure we don't have a negative or a 0 inside the expression. All right, so that's our solving log equations. Those are the kind of problems you guys are going to see. Make sure you're comfortable with the process of condensing them. Make sure you're comfortable with the process of checking your answers for extraneous solutions. That kind of stuff will come up fairly often. All right, only one more topic left in Unit 4. That'll be the word problem section. We're going to interpret word problems and solve equations based on that. So I'll see everyone next time.